Hello and welcome to Teach Up, where we show you how to do well on the AP Calculus test and to do it fast. Today we'll do the following problem on what interval or intervals is the graph of y is equal to 2x times e to the power 2x concave down. Before we start finding what's the answer, we need to first remember that what it means for a graph to be concave down is that at some point we have the curve or the graph of this function having something that looks more or less like this. So what we have here is that the slope of the tangent line, which is the first derivative of the function, is going from a positive value to 0 to a negative value. So here y prime would be less than 0. So when we have a value that's going from positive to 0 to negative, we recognize here that what this means is that y prime is decreasing. And what that means in turns is that y double prime, or the second derivative, is less than 0. So we need to find when is the second derivative of this function going to be less than 0. All right, let's first find the first derivative of the function. So y prime is going to equal to, we're going to factor out the 2, and now we're going to use the product rule. So we're going to have the first function times the derivative of the second function, which is 2 times e to the power 2x, applying the chain rule, plus the derivative of the first function, which is 1, times the second function, e to the power 2x. Now we see here that we have a common factor of e to the power 2x, which we can factor out. So it's going to be 2 times e to the power 2x times 2x plus 1. All right, so this is what we have as the first derivative. Now we're going to go ahead and find the second derivative by taking the derivative of that function. So y double prime is equal to 2 times, I'm going to factor out the 2 again, and we're going to have again the product rule. So we're going to take the first function, e to the power 2x, times the derivative of the second function, which is 2, plus the derivative of the first function, so 2 times e to the power 2x, times the second function, so 2x plus 1. All right, again, I see that there's a common factor here of 2 e to the power 2x, which I'm going to go ahead and factor out. So I'm going to have 2 times e to the power 2x times 2 plus 2 times 2x plus 1. All right, let's clean this up a little bit. Well, here I see there's a common factor of 2. Let me actually just get that out. So you're going to have 2 e to the power 2x times that 2 times the quantity 1 plus 2, 1 plus 2x plus 1. Okay, so what we have then is 4 e to the power 2x times 2 plus 2x. There were a few ways you could have just simplified that, but this is good enough. Let's just stop here and just say we want to know when is this going to be less than 0. Well, we know that this quantity here is going to always be positive. 4 is a positive number, and e to the power 2x is always going to be positive. The range of the exponential function here is going to be always greater than 0. So the only way this function here is going to be negative is if this quantity here is less than 0. So you have 2, let me factor out that 2 times the quantity 1 plus x has to be less than 0. Again, 2 cannot be negative, which means 1 plus x has to be less than 0, which means x is less than negative 1. And that corresponds to the values that are going to be to the left of negative 1. And so that would be everything here from negative infinity to negative 1. So our answer is going to be A.